In this video, I'm going to do OCR A-Level Maths Paper 1 from June 2023, question 5. My name is Sunil Tanna. I'm an author and tutor. I'm available for one-to-one tuition both online and in person. Please like and subscribe. Question 5. The function f of x is defined for all values of x such that f of x is equal to the absolute value of ax minus b, where a and b are positive constants. Okay, the graph of y equals f of x plus c, where c is a constant, has a vertex of 3, 1 and crosses the y-axis at 0, 7. Find the values of a, b and c. Okay, so let's first of all think about f of x graph. If we were to plot a sketch or draw a sketch of f of x, what do we know? First of all, if we do it without the absolute value signs, since these are positive constants here, it would be y equals mx plus c. So it would be a straight line, and it would cross the x-axis, and it would continue downwards here until it eventually crossed the y-axis at minus b here. But because it's got the absolute value, it reflects like this, where it crosses the y-axis at b here instead. So this is f of x, and what we know here is the gradient of this here would be a, and the gradient of this bit here would be minus a, equals minus a. Okay, so what about if we did f of x plus c, which I'll draw on in red. F of x plus c, it would move up by c. So it would move up like this, and it's moved up by c. And this point here would be b plus c. The gradient of the downward part here would still be minus a, so the gradient of that part here would be minus a. Gradient of the upward part here would still be a. What about this point here, the lowest point? So for the original one, we had the y value be 0, and remember this is the positive part of the line here, because we know a and b are both positive constants. So we could do, so that equation of this line here would be y is equal to ax minus b, and since we want the y value to be 0, we can see 0 is equal to ax minus b, so add a b to both sides, divide by a, b over a. So this point here at the bottom would be b over a across and 0 up. Now in the ffx plus c, this point at the bottom here will be b over a across, and it will move up by c. So now we know a couple of things here. By looking at the information that they've given us, we know that the vertex has moved up by to 3, 1. So for f of x plus c, we know b over a is 3 and c is 1. We also know that the y-intercept of this is 7. So b plus c is equal to 7. Since we already know that c is 7, c is 1, we can see that b is 6. And now we know 6 over a is equal to 3. So this tells us a is equal to 2. And we've got all of our constants there. A is 2, b is 6, c is 1. Okay. Part A, Part 2, 5a, Part 2. It says, explain why f minus 1 of x does not exist. So the reason we can't find an inverse here is if we were to choose, we need a unique y value for every x value. You can see, for example, f of 0 would be the same as, if you work it out, it would be f of 6, because it's reflected around the middle part of f of x, yeah? So there's a line of symmetry here. So if you're 3 to the left, 3 to the right would be the same. So it's a one-to-many. F is a one-to-many sorry, a many to one. So many x values give you one y value. Many to one function, e.g. f of 0 is equal to f of 6, so no inverse. Okay, now we're going to do part B, which I will write on a new page. 5b. The function g of x is defined for x is greater than or equal to q over p, where as g of x is equal to px minus q inside absolute value signs where p and q are positive constants. So it's kind of similar to the previous one. Find the term in terms of p and q, an expression for g minus 1 of x, stating a domain of g minus 1 of x, the inverse function. Okay, so in g of x, we can see that the y value would be equal to px minus q. But if you think about what this, we know from this inequality that px, if we multiply both sides by p, is greater than q. So this value here will, inside the absolute value signs, will always be positive. So this tells us that y is actually equal to px minus q. So now we can go into the inverse function of this. So g minus 1 of x, it will be x is equal to py minus q. And we can rearrange that to make y the subject. So x plus q divided by p is equal to y. We could write that slightly differently as 1 over p times x plus q over p. So g minus 1 of x is equal to 1 over p times x plus q over p. And we also need to state the domain of g minus 1 of x. Well, this only worked when x is greater than or equal to 0. So the domain here is x is greater than or equal to 0. Another way of thinking about it is we said here that the absolute value signs don't do anything because px minus q is already positive. So in other words, in the original function, the range is y is greater than or equal to 0. So the domain of the inverse, the domains and range swap, is x is greater than or equal to 0. Okay, and then the last part, B part 2, says state the set of values for p for which g of x equals to g minus 1 of x has no solutions. Well, we already know that p has to be a positive constant, so p is greater than 0, and then we couldn't find an inverse if p is less than or equal to less than or equal to 1. So p has to be greater than 0 and less than or equal to 1. And that completes question 5.